Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study or discuss various types of questions or come across in examinations of both continuous internal evaluation tests and semester end examinations. So I'm going to mention here in the form of all questions are covered in the form of your models. There are 6 models we are going to study here. If you understand thoroughly those 6 models, you can crack any type of question comes in module 1. So far in the previous lectures, the following topics are covered in detail. That is elements or links, classification, rigid link, flexible or fluid links, classification of kinematic pace, classification of constrained motions, degrees of freedom calculation based on Grubler's criterion, and inversions of 4-bar chain, inversions of single slider crank chain, and inversions of double slider crank chain mechanisms. Now let us read. Now some of the things, if you want to find out whether it is a kinematic chain based on Grashoff's law. Now here in the slide it's mentioned that there is a relation between the number of links and the number of pairs. If it satisfies, the mechanism satisfies this equation, then we can call it as a kinematic chain. Now here it is. Okay, call it as a kinematic chain. Now since the relation between number of links and pairs L equal to 2p minus 4, where P is number of pairs and L is number of links. If it satisfies, the mechanism satisfies this equation, then we call it as a kinematic chain. And there is another relation between number of joints or lower pairs to number of links. That is equal to J equal to 3 by 2 times L minus 2. If it is not satisfies, the mechanism doesn't or not satisfy this equation, then that mechanism can't be called as a kinematic chain. Now, what is equation 1? Since in a kinematic chain, each link forms a part of 2 pairs. Therefore, there will be as many links as the number of pairs. So these are the 2 additional 2 equations are to be satisfied of any mechanism. Now, this is consider the arrangement of the 3 links. There are 3 links here, AB, BC and CA, with pin points, with pin joints at A, B and C as shown in figure. That is link 1, link 2 and link 3. The number of links in this figure, there are 3 links, that is L equal to 3. How many number of pairs are here? The pair is link 1 and 3, one pair, link 3 and 2, another pair, and link 1 and 2 is a third pair. How many pairs are there? There are 3 pairs are here. And how many joints are here? Link 1 and 3 joined at A, and link 1 and 2 joined at B, and link 3 and 2 joined at C. The number of joins in this figure is observed equal to 3. Now, let us substitute in the equation, that is L equal to 2p minus subtract 4 2p minus 4, that is L equal to 3. 2 times p, 2 into 3 minus 4, that is 2. That means LHS right hand side, left hand side is value is greater than the right hand side value. Okay, let us go for second equation. That is J equal to 3 by 2 L minus 2, where number of joints are 3 and L equal to 3. Substitute over in the equation, above equation, then again LHS is greater than RHS. So that is, is it kinematic chain? No. It is known as, when LH is greater than RHS, it is known as a locked chain, a locked system. So there is no motion transmission. Coming to second question, same model, the same model. Now in this case, LHS is less than RHS. Now again, it is, there are 5 links are there, L equal to 5. How many pairs are there? P equal to 5 and J equal to 5. L equal to 2p minus 4, substitute L, P and J values in this equation 1, that is L equal to 2p minus 4. Then what happens? L, number of links 5, 2p minus 4 is 6. That means LHS is less than RHS. Then such type of chain is known as unconstrained chain. If you substitute J, 3 by 2 L minus 2, that is J equal to 5, 3 by 2 L minus 2, that is 5.5. LHS is less than RHS value. So it doesn't satisfy the equation of kinematic chain. So such type of chain is known as unconstrained chains. That means the relative motion between the links is not completely constrained. This type of chain is having a very little practical importance. Alright, that is the way we'll decide. Now what should be? It should be LHS equal to RHS. So that is okay, let me complete 4-bar equation, 4-bar mechanism. You use it here. Whether it satisfies this kinematic chain equation or not. So in the case of 4-bar chain, 1, 2, 3, 4. So L equal to 4, number of pairs equal to 4, number of joints equal to 4. So what is L equal to 2p minus 4? L equal to 4, 2 into p, 2, 4 minus 4. Then what will happen? 4, that is LHS equal to RHS. Then it is a kinematic chain. That's why we have studied in the previous lectures. This is a 4-bar kinematic chain. Yeah, another equation, if you substitute, what is that? J equal to, if you substitute, what is that values? J equal to 3 by 2 times L minus 2. J equal to 3 by 2 times, what is the equation? J equal to 3 by 2 times L minus 2. What is the J? 4. 3 by 2 L is 4 minus 2. Yes, again it is satisfied. That is LHS equal to RHS. 4 equal to, because 2 times 2, 3 to 6, 6 minus 2, 4. That is LHS equal to RHS. That means 2 equations are satisfied. Then that's why it is called a kinematic chain. Okay, 4-bar. So thus we can check the given mechanism is a kinematic chain or not based on these rules. Alright. Now that is model 1. Very, very important question in continuous internal evaluation examinations. Continuous internal examination. Yes. Now coming to model 2. This model 2 is discussed based on Grubler's criterion. That means in order to calculate the degree of freedom of various plane mechanisms consists of lower pairs and higher pairs. In one of the author written in India, that is Ratan, S.S. Ratan, Theory of Machines by Ratan. He mentioned that other criterion, one of that is based on number of loops. Yes, it is only having limited applications only when it is loops are there. If there is in the mechanism, if there are any slider links or higher pace, then that his criterion can't be valid to calculate degrees of freedom of such type of mechanisms. Now here, if we observe here, there is a sliding pair is there in this figure. We can't use that Ratan criterion formula based on number of loops, etc. We have to go for Grubler's criterion only. It is the lower pair. So his formula, there are various notations. We have studied in previous lecture 3 into n minus 1 minus 2l minus h. Here different notations 3 into n minus 1 where n stand for number of links. P1 here number of lower pairs, no. This is P1 number of lower pairs he considers single degree of freedom. And P2 is a 2 degree of freedom systems. That is nothing but higher pairs. You can use any one of the formula. Now here in this problem, how many links are there? All fixed links are considered as one link, link 1. Alright. And how many total number of links? Link 1, 2, 3, 4, 5, 6, 7, 8. Number of links n equal to 8. And how many joints are there? How many joints? This is one joint, 1, 2, 1, 2. This is a ternary joint. 1, 2, 3, total how many? With this 4. 1, 2, let me come to this one. 1, 2, 3, 4, 5, 6. 6, how many joints are there? This is the ternary 6 means 6 plus 2. 8. Okay, yeah, okay, 8. And with this 9, one more joint. It is 10. That is L equal to 10. How many higher pairs are there? Higher pairs H equal to 0. So here, all of you pay attention. It is 1, 2, 3, 4, 5, 6, 7. 7 plus how many here lower pairs are there? 7 plus, for with this to width is 8. 7 plus 1, 8. This is a ternary joint. Link 3, 4, 5 is ternary. One ternary joint equal to 2 binaries. 2. That is a 10. L equal to 10 lower pairs. Substitute in this formula 3 into 8 minus 1, 2 times 10 minus 0. That is 21 minus 20 equal to 1. So the degree of freedom of this mechanism is 1. It is, this mechanism is a single degree of freedom system mechanism. Alright. Now under model 2, second problem, very important. Here we considered the redundant degree of freedom. This is the final formula. F equal to 3 into n minus 1, 2l minus h minus redundant degree of freedom. Now, why redundant degree of freedom? If we operate this link L, then there is no effect on that link. If it slides, there is no effect. It is a parallel connection. So the number of links, how many are there? 1, 2, 3, 4. 4 links. That is 3 into 4 minus 1 minus 2 times. How many lower pairs are there? How many lower pairs? Link 1 and 2. 1 lower pair, L1. Link 2 and 3, L2. Link 3 and 4, L4. Link 4 and 1, L5. Total, how many lower pairs are there? 1, 2, this is 3. 1, 2, 3, 4. 4 pairs. 2, L4, 2, 4. Minus, what is higher pairs number? 0. What is redundant degree of freedom? The redundant degree of freedom is equal to 1. Okay. Now substitute will get 0. So it is a locked system. There is no transmission of motion among these links. When we apply to one of the link, any motion to one of the link, it can't be transferred. So when the degree of freedom equal to 1, then it is called a what? Locked system. Alright. Now the problem number 3. This problem is solved here or is given by considering the higher pair contact. There is 6 and 3. The contact between 6 and 3 is higher pair contact. What is our formula again? F equal to 3 times n minus 1 minus 2 times lower pace minus higher pace if you want redundant degree of freedom. This is the final formula. Here redundant degree of freedom Fr equal to 0. And how many links are there? Here in this figure it is mentioned directly. How many links are there? There are 7 links are there. 3 into 7 minus 1 minus 2 times L. What is the 2 times L? Number of lower pairs. Lower pairs contact 1, 2, 3, 4, 5, 6, 7, 8. So number of lower pairs are 8. Next, how many pairs? 6 and 3. One higher pairs. What is the degree of redundant degree of freedom? Equal to 0. That is 3 times 6, 18 minus 2 times 8, 16 minus 1 minus 0. That is a single degree of freedom. It is a mechanism with 1 degree of freedom. It is a mechanism with 1 degree of freedom. So thus we covered model 1 and model 2. Alright. Now coming to model 3. In this model 3, we are going to find out all the inversions of the chain given in figure. All the inversions of the chain given in figure. So what are the inversions are? Now we'll apply by using based on Grashoff's law. If the shortest link is fixed, whether it is a kinematic chain or not, based on Grashoff's law. Grashoff's law indicates condition for transmitting motion among the links based on the length of the links. What is that? L plus S is less than, should be less than, equal to P plus Q. The length of the longest and shortest link. What is the longest? 12. Shortest 3 should be less than 10 plus 8. Yes, it is a kinematic, it is a chain. So when it is like that, how many inversions? There are 3 distinct inversions are possible. We have to check with that condition. If the shortest link is fixed, if the shortest link 3 millimeters, shortest link is S, longest link is L, and another is P and Q. If shortest link S equal to 3 millimeter is fixed, then what will happen? 12 and 8 millimeters link, that is L and P, having complete rotations. That's why it is called double crank mechanism. Complete revolutions. And the link opposite to the shortest link is fixed. Opposite to the shortest link is 10 millimeters. It is fixed. Then what will happen? Then 12 and 8 millimeters, L and, as I mentioned before, P. This L and P acts as rockers, oscillations. That's why it is called double rocker mechanism. Okay. And link adjacent to the shortest link is fixed, any one. Then what will happen? Crank rocker mechanism. Thus, we'll define, I have already mentioned, solved this problem in the previous lecture, in the lecture of double crank linkage. Now, that is 3 models are covered. Now, 4th model is very, very important, 4th and 5th models. And, okay, total 6 models as I mentioned before. In this 4th model, the length of the fixed link of a crank and sorted lever mechanism is the length of the fixed link of a crank and slotted lever mechanism is 250 millimeter and the depth of the crank is 100 millimeter. Determine. Very, very important. There are three objectives are there. Number one, inclination of the slotted lever with the vertical. This is a slotted lever with the vertical. This inclination. That inclination be alpha by 2 or beta by 2. We'll see. Now next. Now we want, these are the fixed link given. The length of the fixed link, that is 250 millimeter. And the crank position was given. Okay, based on the notations, this is the crank position 100 millimeter. This is 250. We want vertical angle. Okay. Then how it comes? We will see. This is 90 minus alpha by 2. Based on your notation, whatever notation may be, this angle we require. This 90 minus alpha by 2, that means sine 90 minus alpha by 2, how it comes? Then we have to find out the angles. That is what? And ratio of the time of cutting by time of return and length of stroke we want. Let us see. This is what mentioned here. As is shown here, this alpha by 2, it is beta by 2. We know that cos from this. Now one more thing, R dash, R double dash equal to S dash and S double dash. R dash, R double dash equal to S dash and S double dash. Now cos beta by 2 from this triangle OA and P dash. Then cos beta by 2 that is equal to adjacent side OP dash by hypotenuse OA. That is OP dash by OA. What is it OP dash? OP dash is the length of the crank, that is 100 millimeter. OA is the length of the fixed link, that is 250 millimeters, that is 0.4. Now beta by 2 equal to 66.4 degrees and beta equal to 132.8 degrees. Now what is the first objective? The first objective is we want alpha by 2. How it comes? Angle of slotted lever with the vertical, that is alpha by 2 equal to 90 minus beta by 2. This alpha by 2 equal to 90 minus beta by 2. 90 minus beta by 2 is 66.4. 90 minus beta by 2, that is 23.6 degrees. That is the first objective. Next objective, what is the time of cutting stroke to time of return stroke? That equal to 360 degrees minus beta by beta. That is 360 degrees minus beta value is 132.8 degrees by 132.8. That is 1.71. It is greater than 1. Now, final third objective is length of stroke. The length of stroke, as I said here, S dash, S double dash equal to R dash, R double dash. This S dash, this is nothing but is again another right angle triangle. Alpha by 2, how it comes? R. We want R dash R, R dash R double. That is called R dash R double dash. R dash R equal 2 times R dash R equal to R dash R double dash. Now 2 times R dash R, that is nothing but AR. That is 2 times AR sin alpha by 2. Again it is right angle triangle, sin alpha by 2. 2 times AR sin alpha by 2. What is that AR? AR is nothing but the length of the slotted lever. The length of the slotted lever was given. The value is given in the problem. Value is given. Now the 450 sin alpha by 2. What is it alpha by 2? 23.6 degree. Now if we calculate, then the value is obtained at 360.3 millimeter. This is the model number 4. Okay, alright. This is the way you can solve the number of problems were mentioned, were shown in this lecture. The same problem, the same model as the model 4 category. Very simple. In this, what they mentioned, find the ratio of the time of cutting to the time of return stroke. Let me read what the data was given. Here, a crank and slotted lever mechanism used in a shaper has a center distance of 300 millimeters between the center of the oscillation of the slotted lever and the center of rotation of the crank. That is the length of the fixed link. And the radius of the crank is 120 millimeter. In this figure, in the previous figures, it is AP dash equal to AP double dash equal to 120. Now, what is that AC here? Yeah, Find the time of cutting ratio, that is at 360 degrees minus beta by beta. That's what we want, a beta. Okay, how to find out the beta? Again, same notation you use or different notations, no problem. But if you know the concept, no need to apply notations also. Let us begin. That is AC. In before figure, it is O. It is mentioned as a P. It is A. Okay, it is A and O. No problem. This is alpha by 2. Different notation, but purpose is same. We want alpha by 2. How it comes? Sine 90 degree minus alpha by 2. If you know, so sine 90 minus alpha by 2, what will happen? Or cos beta by 2 also. There are different ways are there. Cos alpha by 2, that equal to CB1 by AC. Okay, from that alpha comes. Alpha by 2 comes. So 90 minus alpha by 2, that equal to beta. That is beta by 2. Alright, thus if you follow based on these notations, sin CAB sin 90 minus alpha by 2, sin 90 minus alpha by 2 from this triangle, sin 90 minus alpha by 2, what will happen? Opposite side by hypotenuse, that is BC1 by AC, that is 0.4. Then 90 minus alpha by 2 equal to sin inverse of, that is 23.6 degree. Then alpha equal to 132.8. So time of cutting stroke, what is the time of cutting stroke with time of return stroke? 360 degrees minus alpha, or you can make it based on beta also. Here the lower considered as a beta, don't get confusion. What is that angle you have to see? 360 degree minus beta we followed in the previous problem. In some of the books, they followed notations upside down, but you can follow based on the previous question exactly, you will get it. 360 degree minus 132.8 by 132 point, that is 1.72. It is again greater than 1. So time of cutting by time of return strokes. So you can follow, these are the questions, better you can follow the same model. In this we mentioned what to be found. Find the inclination of, again, the slotted lever bar with the vertical in the extreme position and the time ratio of the cutting stroke. Okay, and also same thing, they are given here the length of the slotted bar, we have to find out the length of the stroke. Again, 3 objectives. What are the objectives are? 90 minus alpha by 2 is the first objective, and the second objective is time of cutting by time of return, and third objective is line of stroke or length of stroke. R1 or 2 here they mention in the figure. You follow the problem which I have shown before completing the starting of this model. That methodology you follow completely same notation, you will not get any confusion. Alright, this is the same procedure you follow. What is the first objective? Sin 90 minus alpha by 2. 90 minus alpha by 2 is the objective, and whatever time of cutting stroke to time of return stroke, same methodology you follow. And it is a problem, R1 R2 equal to P1 P2, that is 2 P1Q. What is the 2 P1Q? I said P1 AR sin alpha, 2 A P1 sin 90 minus alpha by 2. You follow exactly, it will be obtained. Very important model it is for examination point of view. The same thing, this is also model. In previous questions the objectives are vertical angle and the length of the stroke and time of cutting to time of return. In previous problems mentioned here, very important problem is that they were given length of the strokes values and time of cutting and time of return. We have to find out the dimensions of the crank and fixed link AC and AP. Fixed link AC and AP or CB. Yes, those are the things we have to find. It is the reverse. But if you are thorough in the previous concept, you can solve easily the same things if you are following. Alright, everything mentioned here step by step. You can pause the screen and follow the answers. You will get it. It's very simple. I'm not skipping out. This is an exercise I'm giving to you. If you thoroughly understand the initial problem of this model with concepts thoroughly and substitute the data properly, then you will get what is we require. There is always one unknown, they will give you input parameters. That is the concept. We will get that unknown by using the concepts of crank and slotted lever mechanism. Now module 5, in this module 5, this is module 5 is Whitworth quick return motion mechanism. Okay, in the Whitworth quick return motion mechanism, so far before module 4 is based on crank and slotted lever mechanism. Don't get confusion. This is Whitworth quick return motion mechanism. In this Whitworth quick return motion mechanism, the distance between the fixed centers CD, that is 50 millimeters, and the length of the driving crank is 75 millimeters, that is CA 75. This is the driving crank, it is the fixed centers, 75 millimeter. The length of the slotted lever is 150 millimeter. What is the length of slotted lever? This is PA. The PA is 150 millimeter. And the length of the connecting rod is 135 millimeter. What is the length of the connecting rod? That is PR. Where is the PA? Sorry, PA is 150. This is PA, 150 connecting rod. The length of the slotted lever is a PA. This is 135 millimeters. Yeah, am I right? Yeah, 135 millimeters. That is the length of the connecting rod. This is the length of the slotted lever. PA is the length of the slotted lever is 150. PR is 135. So this is the data are given. But then what to do? Find the ratio of, again, time of cutting to time of return. So also find the effective stroke length, the length of the stroke. Let us begin how to find out. Find the ratio. Yes, these are the things. There are two objectives in this problem. Now, if you define it properly, this is the figure is given here, 30 degree. Now, it makes 30 degree. It is beta by 2 as this figure. It is beta by 2 with A2, C and D is one of the triangle. Now, sine beta by 2, cos beta by 2 equal to, based on the required data, that equal to CD by CA2. Cos beta by 2 means opposite adjacent side by hypotenuse. That is a diagonal. That is CD by CA2. What is the CD here? 50 by 75. These are the data we know, known data. That's why we took it as cos beta by 2. Otherwise, we will consider sin beta by 2 also. If we consider sin beta by 2, we don't know A to D. We know A to D, AD, we don't know. So the required based on the known parameters, then beta by 2, beta equal to 96.4 degree. Now we know the beta. What is the time of cutting stroke to time of return stroke? Cos 360 degree minus beta by beta. Substitute over here. That is 2.375. Very important is that here in this case, as we have studied in the length of the strokes of a crank and slotted lever mechanism, we can't find out here. It is little bit complicated in comparison to the crank and slotted lever mechanism. So the length of the stroke, find the length of the effective stroke, that is R1, R2. That R1, R2, for that we have to draw the space diagram of the mechanism to some suitable scales based on the data. This one you draw. Then mark P1 R1 equal to P2 R2. Where is the P1? This is the P1 and R1. P1 R1. This is the P2. P2 R2. Then that is equal to PR. If you make it, then if you measure it, then length of the effective stroke, that is R1 R2 is observed. The R1 R2 observed value is 87.5 millimeter. This is, we have to draw the space diagram because the details were given. CD was given, CA, CP and PR. All the values were given so that we can draw space diagram and we can find out the effective stroke length. It is only for this methodology we have to follow for Whitworth quick return motion mechanism. Alright, this is the model number 5. The final model is a sixth model. It is for inversions of one of the mechanism, that is Oldham's coupling. This Oldham's coupling means a double slider inversion of double slider crank chain mechanism. So what to be here? The distance between two parallel shafts is 18 millimeters and they are connected by an Oldham's coupling. The driving shaft revolves at 160 rpm, revolutions per minute, 160 revolutions per minute. What will be the maximum speed of the sliding of the tongue of the intermediate piece along its groove? So there is a formula that is called omega times d. This d is a distance between parallel shafts, that is 18 millimeter. What is this omega? Omega equal to 2 pi n by 60 times d. So 2 pi, omega equal to 2 pi n by 60, and sliding velocity, that is sliding velocity linear, that is v equal to 2 pi n by 60 times d. What is n here? 160 millimeters by 60 times. Convert this 18 millimeter value in the terms of meters, that is 0.018. Then the value can be observed as 0.302 meters per second. The maximum velocity of sliding, omega d, that is 0.302 meters per second. In this we covered session all 6 models of module 1. If you thoroughly understand number of times or thoroughly understand if you work, you can crack any question comes from module 1. Now these are the question bank questions. Let me revise it for 10 to 15 minutes so that we can complete question bank questions also in module 1, which we have given in our your login uploaded document. So the first question, if you understand whether we covered or not, you verify it. In this lecture I covered all the problems which I am going to show you. Yeah, the Whitworth quick return motion mechanism has the driving crank 150 millimeters long. The distance between the fixed centers is 100 millimeters. This is 150 millimeter. The line of the stroke of the ram passes through the center of the rotation of the slotted lever, whose free end is connected to the ram. Find the ratio of the time of cutting to the time of return. We covered the time of cutting stroke to time of return just now. What is that question? Whitworth quick return motion mechanism. This is the question given here. But in this question it was detailed. What we need exactly, what is required, they are given directly. Why here detailedly? Why is it given in this? Because we have to find out the length, effective length of the stroke. That's why they mentioned all dimensions of the links. But in the problem, not required. They find out only time of cutting to time of return. Next, in the crank and slotted lever mechanism, please you read carefully. It is covered already, the same model. That is, the distance between the fixed centers is 150 millimeters and it is 75 millimeters the length of the crank. Again, it is related to the crank and slotted lever mechanism, that is time of cutting to time of return. Both are problems, that is critical thinking questions. Now, what is sketch and explain any two inversions of double slider crank chain? Any two inversions. One of the inversion is what? Oldham's coupling. Another inversion, you can go through this, that is that is elliptical trammel. You can write, there are 3 inversions are there, any 2 you can write down. Then what is the difference between Whitworth quick return motion mechanism and crank slotted lever mechanism? Yes, this is what is the difference. The differences between Whitworth quick return motion and slotted lever mechanisms. Alright, this is a theoretical question you can. Now, question number 5. Sketch and explain the various inversions of again, same repeated question in different manner. Double slider crank chain mechanism. First inversion is, what is the first inversion of double slider crank chain mechanism? Elliptical trammel. What is the second inversion? Scotch yoke mechanism. What is the name of third inversion? The third inversion is Oldham's coupling. Question number 5 answer. The answer for question number first inversion, the inversion 1 is elliptical trammel. Second inversion is, what is the second inversion is? Scotch yoke mechanism. Third inversion is Oldham's coupling. Alright, these are the 3 things you can. Then again, I changed numericals here. Numericals are changed, but it is the same problem. But the line of stroke of the ram passes through the center of the rotation of the slide. What is the objective? Find the ratio of, again, time of cutting to time of return. That comes under model number 4. Okay, Whitworth, model number 4. Crank and slotted lever comes under model number 5. No, let me check it. Sorry, model number 5 is Whitworth. Model number 5 is Whitworth. Crank and slotted is model number 4 in this session, in this lecture. Now, sketch and explain any two inversions of. Yes, again, same question. Then again, what is the difference between Whitworth? Yes, questions are repeated. Sketch and explain various inversions of 4-bar chain. In before lecture, I covered 4-bar chain, various inversions based on the Grashoff's law. If we fix the shortest link, it obtained as a double crank mechanism. Shortest link is fixed. Then what happens? A double crank mechanism. Link opposite to the shortest link is fixed. That is longest link is fixed. Then what happens? Double rocker mechanism. Link beside shortest link is fixed. Beside the shortest link is fixed. Then what happens? Crank and rocker mechanism. Like that, different inversions are obtained. Okay. These are the very, very important questions. Those are all, so far we covered critical thinking. Of course, it is not critical thinking. Some of the mixed are based on conceptual wise. Okay. Now coming to long answer questions. Long answer questions explain the kinematic pace and inversions of double slider crankchain mechanism. Already covered. What is double slider crankchain? Define machine and mechanism. Enumerate the inversions of slider crankchain mechanisms. Yes. Inversions of single slider crankchain mechanisms. What are they? There are 4 inversions are there. Each inversion consists of how many? There are 2 applications are there. Now explain the quick return motion mechanism. Yes, it is comes under the quick return motion mechanism of what? Crank and slotted lever. It is model number. Yes, what is the model number? 4. Yes, identify the difference between a machine and a structure. Classify kinematic pace. Yes, there are various classifications based on nature of contact, lower pace and higher pace, based on the mechanical constraint, open pair and closed pair, based on relative motions. There are 6 types are there. Okay, those are called spherical pair, okay, turning pace, etc. That's what. Again, same question, very important. It is a Whitworth quick return motion mechanism. It is model number 5 in this session. Please go through it thoroughly. We covered in detail level. Alright. The length of the slotted lever given and the length of the connecting rod. Find the time of cutting stroke and the effective stroke. In the Whitworth quick return motion mechanism, effective stroke length can be drawn by using can be calculated by drawing the space diagram. Next question, define machine structure. Again, explain different types of constrained motions. What are the different types of constrained motions? Completely constrained, incomplete constrained motion, and the third one is successfully constrained motion. Alright. Now, explain the functions of a Oldham's coupling. Prove that elliptical triangle describes an ellipse. Okay. This elliptical triangle x square by a square plus y square by b square equal to some constant comes. Alright, this is what you have to follow. Or that equal to 1. X in this session, we covered in before session. Go through it. Now, these are the questions. Define inversions of a mechanism. Explain the inversions of quadric cycle chain. This quadric cycle chain is nothing but 4-bar chain. Explain Grubler's criterion. What is the Grubler's criterion? 3 into n minus 1 minus 2l minus h. We have to explain it. That is the degree of freedom. Identify the degree of freedom for what? 4-bar mechanism equal to 1. Slider crank mechanism is also equal to 1. But 5-bar mechanism will get it as, I think so. 5-bar mechanism equal to more than 1. Now, what is meant by degree of freedom of a mechanism? What is meant by degrees of freedom of a mechanism? Explain the applications of Kuchbek criterion to plane mechanisms. Yes, according to the standard mentioned, the standard book, that is Ratan's book, he mentioned that Kuchbek criterion is nothing but a Grubler's criterion. In some of the textbooks, they called as Grubler's criterion as Kuchbek criterion. Now, next question. A crank and slotted lever mechanism used in a shaper. Yes, this model is covered. This is a crank and slotted lever. Model number. What is the model number here? Anybody? 4 in the session. Total 6 models are there. 6 varieties of problems are covered. It comes under model number 4. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.